So folks, in this section I want to review graphing lines. There's a lot of ways to graph lines, and there's a lot more to study about lines than just looking at their graphs. But for right now, we'll just jump into it. I want to remind you that whenever you want to graph an equation of two variables, this is two variables, the independent variable x, the dependent variable y. Whenever you want to graph an equation of two variables, you can always point plot. And sometimes that's called building a table of values, where maybe you pick an x-coordinate. So let's pick the x-coordinate 1. And so we'll pick this, and then we'll figure out that y would be equal to 2 times 1 plus 3. Oops, excuse me, that should be minus 3. Minus 3. And if we simplify that, we get y is equal to minus 1. Put another way, we've just found that we've got the ordered pair on this graph. The independent variable x is 1, and then the dependent variable y would be minus 1. Okay, so we picked x was 1, and then we found this. So we could do this again. We could go ahead and pick, I don't know, how about something like x is equal to minus 2. So then what we'll do is we'll find that y is equal to 2 times minus 2 minus 3, which would be equal to negative 7. So that would give us the ordered pair negative 2, negative 7. There's nothing that says we have to pick x coordinates, although usually we think of x as an independent variable, and so it's best to choose that. But we could have also picked y to be some number. So let's go ahead and pick something that's easy to work with. Let's go ahead and pick y equals 0. And so in this case, what we'll do is we'll find that x would be what? Well, we'll go ahead and plug in 0 for y, and we have 0 needs to be equal to 2x minus 3. And if we solve this for x, we'd have 3 has to equal 2x, or x is equal to 3 halves. And so what we just did here was we found that we had the ordered pair 3 halves, 0. Okay. So we can now that we've got several points, because we happen to know that this is the graph of a line, and I'm not going to review that right now except to say that this is a linear equation. Roughly speaking, you could say we have no division by variables, we're not taking natural logs of variables or taking the sign of any variables, and all of our variables expressions are raised to the first power. That isn't quite the definition of a linear function, but that might help jog your memory a little bit. So we know this is a line, so it's actually enough just to graph. We've got 1, 2, 3. It's actually enough just to graph 2 of these 3 points, but we'll go ahead and graph all 3 just for kicks. So let's go ahead and do so. We've got, let's see here, here would be the ordered pair 1 minus, there's the x coordinate 1, the y coordinate minus 1. So there's that first ordered pair that we just plotted. Okay, I meant to make that blue. Let's try that again. There's that first ordered pair that we just found. Let's go ahead and plot the ordered pair negative 2, negative 7. So if we were to go to negative 2, negative 1, 2, negative 1, 2, 3, 4, 5, 6, 7. My scale's not perfect there, but this will get the point across. There we have it. And then we could also plot the ordered pair 3 halves, 0. So let's see here. 3 halves should be somewhere in between 1 and 2, and on the x-axis, where x is 3 halves. And so we end up with this point right here. And now I'm going to try my best, folks, to draw a straight line. I'll probably end up erasing it and putting one in more carefully. And so there you can see I've sketched the graph of this line. We did this through this very, and I want to emphasize this, folks, this very inefficient method of point plotting. And I need you to realize, if this is your favorite way to graph a function, I need you to realize that this way will not always work well for you. And in fact, most of the time, it is not how we will graph functions. So please, even though this one method makes a lot of sense, I feel like it's pretty clear. You take an x coordinate and find a y, or you take a y coordinate and you find an x, and then you plot those points. That is an inefficient way to graph. Instead, we're going to make use of the fact that we know something about these linear equations, and there were 3 forms of linear equations that you've studied in your previous classes. The first one was our general form that we studied, and it looked like ax plus by equals c. And I'm going to tell you that this is useful for finding intercepts. And I'll show you what I mean by that in a moment. The second form of line that we studied was the slope-intercept form. If you were to poll a bunch of students what their favorite form of a line is, they would usually tell you that they like the slope-intercept form. It's the form that looks like y equals mx plus b. And I will say that this is useful for graphing. However, I would argue that there are plenty of instances where this general form will be just as helpful or perhaps even more helpful, and maybe one of these examples will highlight that for you. The final form of a line that we have that we often deal with is the point slope form of a line. The point slope form of a line looks like this. It looks like y minus y1 is equal to m times x minus x1. And here I'll just remind you that x1 comma y1 is a fixed point on the line. If you were to poll students again, 100 students, and ask them for their favorite form of the line, this one usually winds up dead last. It is usually their least favorite form to study. I'm here to tell you, though, that this is actually going forward in your math career. It's going to be the most important one. We're not going to look at the point slope form of the line in this particular pre-work. We will have a second pre-work that will highlight its usefulness there. I'll tell you now that this is useful for building the equation of a line. Whenever we're asked to come up with a line, come up with an equation for a line, we will more often than not use this form. And hopefully that gives you a little bit of a hint as to why we like it so much. Okay.